Good day, everyone, and once again we are back together. So I interrupt your day just to look at this question because I've been getting quite a number of, inquiries on how to really look at questions that have to do with percentage. So I'm just going to go right into it, and do the KC question. Right. So I've taken it from the Limpopo question paper, the prelim, and it says initially we've got 3.75 moles of hydrogen and 4.5 moles of iodine that were sealed in a 2 cubic decimeter container and heated at 100 degrees. At equilibrium, we've found that we've got 20% of hydrogen gas that is left. All right, so they want us to calculate the equilibrium constant. Now, I want to show us very quickly how to deal with percentages. So in this case, obviously, I'm not too sure why I'm not leaving enough space. Okay, so obviously we're going to draw our rice table, some of you call it. Okay, so we'll have initial as per usual, right? That's in moles. That you'll have change in moles. You can fast forward this part until you get to the part where I actually put in the values. So we've got hydrogen, we've got iodine, and we've got 2HI. That was their reaction, right? Okay, so sorry, that was equilibrium rather. So that's in moles as well as equilibrium concentration, and that's in moles per cubic decimeters. Please make it a point that you always put in the SI units so that we know what's in the box. Right, now let's put in the values. So we've got 3.75 of hydrogen, we've got 4.5 of iodine, right? And of course, when we started, it was only just hydrogen and iodine, so it means hydrogen iodide had not been formed, right? Now they say to us, we've got at equilibrium, we've got 20% of hydrogen that is left. Okay, so it means I'm going to take the number of moles of hydrogen, so that's 3.75 multiplied by 20 over 100. Okay, so in this case, that's 3.75 3.75, okay, multiplied by, remember, 20 over 100, that's 0.2. So I can just say 0.2. So it means I've got 0.75. Now, you need to be careful when you look at this, right? They said 20% of hydrogen is left, right? So sometimes they may say 20% of hydrogen, in this case, was used during the reaction. Okay, so in that case, you would put it as part of the change in moles, but this time around, they specifically said it was left. Okay, so that means this value would go at equilibrium. So just be careful of the language there. All right. Now, as I always say, the change part, of course, now I can do that in the red, right? In this case, 3.75 I started with, and at the end I've got 0.75, so it must mean that I must have used 3 moles. And this is where I can use my ratio. For every 1, there's 1. Okay, so for 3, there'll be 3. Okay, for every 1, there's going to be 2. So in this case, for 3, there'll be 6, twice the amount, right? And of course, I started with 4.5. Okay, so back to my color. So I started with 4.5 moles. I used 3. What do I have? I've got 1.5. I started with nothing. I produced 6. And at the end, I've got 6. And of course, we can now, of course, I think the rest is history when it comes to this question. So we can take, in this case, our volume was given as 2 cubic decimeters, right? So I'll have 0.75 divided by 2, divided by 2. Okay, so that would be 0.375. And there I'll have 0.75 and 6 divided by 2 would be 3. And of course, we can now say Kc is the molar concentration of hydrogen iodide squared divided by hydrogen times iodine, right? Um, right. So in this case, all we simply do, remember when you substitute, you use round brackets. So this is going to be 3 squared divided by 0.375 and 0.75. And of course, ladies and gents, you can find your final answer there. So we're going to say 3 squared divided by 0.375 times 0.75. Okay, and I get my answer to be 32. Remember that Kc does not have any units. So, and that is how the cookie crumbles. I hope that you were able to understand and enjoy that question. Right, and I'll see you again with another very interesting question. From me for now, I'll see you next time. Sharp, sharp.